Hello everyone. So today we will be continuing our same chapter, which is named as acid, base and salts. Okay, so in our last video we have already seen about the indicators, natural indicator, how do they help us in knowing the nature of the substance. Now we will be saying about the synthetic indicator. Okay, so it is man-made chemical substance that is used to determine the nature of the substance. It is not something which we get from nature, right? It is not natural. So it is something which is synthetic or artificial, which is made by man, and it is a chemical substance. It is used to determine the nature of the substance. Okay, so let us see example of it. So there are two examples like methyl orange and phenolphthalein. Now how do they help us in knowing whether the substance is acidic or basic? Is they also change the color. Okay, now in acidic medium, methyl orange gets red color, and in basic medium, methyl orange gets yellow color. Okay, so this is how methyl orange help us in knowing the nature of the substance. In acidic it becomes red, and in basic it becomes yellow. Whereas when we talk about phenolphthalein, in acidic medium it is colorless. Okay, it is colorless, and in basic medium it becomes pink color. So this is how phenolphthalein or methyl orange or any synthetic indicator help us in knowing the nature of the substance by changing its color. So here we complete the indicator topic. Okay, now we will be moving to our next topic, that is concentration of solution. That depending upon concentration we have two types of solution. One is dilute and the other is concentrated. So let us see what they are. So let us take an experiment. We are taking two beakers, and in these two beakers we will be adding 3 cubes of sugar. Okay, so these are 3 cubes of sugar. Now I will be pouring some amount of water in it. So here I am pouring some amount of water in first beaker, which is having less amount of water comparing to that of the second beaker. Here I am pouring more water, right? So now the amount of sugar was same in both, right? That is, in the first one I was having 3 cubes and the second one I was having 3 cubes. But what is different is the amount of water. So the one which has more amount of sugar and less amount of water is called as concentrated solution, and the other which has less amount of sugar and more amount of water is called as dilute solution. So it depends upon the amount of water in the solution. If the amount of water is more, then the solution will be dilute, and if the amount of water is less, then the solution will be concentrated. So in the same way, when we talk about concentrated acid, in this type of acid the amount of water is less and the amount of acid is more. Okay, and when we talk about dilute acid, in this the amount of water is the amount of water is more and the amount of acid is less. Okay, so it's not necessary that these can be the two different type of acid. Okay, if I talk about hydrochloric acid, so hydrochloric acid can be concentrated and it also can be diluted. Okay, so concentrated, if I want hydrochloric acid concentrated, what I have to do is I have to take more amount of acid and less amount of water, or no water I can say. And when I talk about dilute hydrochloric acid, so in that what I have to do is I have to add more amount of water in the hydrochloric acid so that it becomes diluted. Okay, so if any substance or any solution is dilute or concentrated, what you should conclude that the amount of water is more or less in that particular substance. Okay, if concentrated, which means amount of water is less, and if dilute, which means amount of water is more. So this is how we can categorize them as concentrated solution or dilute solution. Okay, now let us go forward with the strength of the solution. So depending upon the strength of acid, we categorize them in strong acid and weak acid. Now what this exactly means? So In strong acid, what happens is the acid ionizes completely in the solution. So if I add the acid into a solution or water, the acid is going to ionize completely. So it is going to give the greatest number of hydrogen ion when it is placed in water or any solution. Okay, so acid which is strong, if we say an acid as a strong, what does it mean? It means that when we place it or when we add that acid into water or any other solution, it is going to dissociate completely. What do you mean by dissociation or dissociate? It means it is going to split itself into hydrogen ions. It is going to give off the hydrogen ions into the solution. Let us see it with the help of an example. So hydrochloric acid and nitric acid, these are two examples of strong acid. Why they are strong acid is because hydrochloric acid splits into H plus and Cl minus ions when it is added to any solution. So you can see fully we have separated hydrogen ions from the hydrochloric acid. It has dissociated all of its hydrogen ions, right? So this is why it is called as strong acid. In the same way, when we talk about nitric acid, it is also going to give its hydrogen ions and NO3 minus will be separated. Okay, so this is what difference is there. When we talk about strong acid, it means that it is going to give all the H plus ions into the solution. Okay, it is going to ionize completely. Okay, ionize completely. Ionize means what? All the ions, hydrogen ions, are going to come off out of the acid. Okay, it is going to get off out of the acid. Okay, so when we talk about HCl, that is hydrochloric acid, the hydrogen ions are going to split out from the hydrochloric acid, and that is why it is called as strong acid. Okay, so this is what a strong acid is. So all the acid particles dissociate and release the hydrogen ions in the solution. Also we can say that the reactants turns completely into product. Reactants means this one, hydrochloric acid is a reactant. It is going to give the product completely. We cannot get the reactant back when we have the product. Okay, so this is all about strong acid. So when we talk about strong acid, it solely means that it is going to split itself into hydrogen ions and the other substance. Okay, so I hope that when we talk about strong acid, it means ionizing completely. That is very much clear. Okay, so this was about strong acid. Opposite to this will be with weak acid. So when we talk about weak acid, it is going to have less dissociation or less ionization capacity. Okay, so acid that doesn't ionizes completely in the solution is called as weak acid. It gives less number of hydrogen ions when placed in a solution. In strong acid, the hydrogen ions were greater, right? More amount of hydrogen ions were dissociated. But when we talk about weak acid, less number of hydrogen ions will be given out when it is placed in a solution. So again we will see an example, ethanoic acid and carbonic acid. So let us say ethanoic acid to see how does it happens. So ethanoic acid, when we dissociate or when we place it into the solution, it is going to give us H plus and CH3 COO minus. Okay, so this is, what is this? This is hydrogen ion which is coming out from the weak acid, but you can see not all hydrogen ions are splitted out. Okay, here still H3 is there, right? Only the H which was there at the end of COOH, that has come out. This H is still there. Okay, so it has not dissociated completely, not at all dissociated completely, and that is why here you can see there are two arrows. One is this and the other is returning back. So if you add this into here, you can get CH3 COOH again, right? So this is reversible reaction. Okay, you can get the product, you can get the reactant again. So this part is undissociated, here it is dissociated, but it is not completely dissociated. It is partially dissociated, means here less number of hydrogen ions have been taken out. Okay, so ionization is not complete when we talk about weak acid, and that is why it is called as weak acid. And we can get the product, we can get the reactant again from the product, that is why it is called as reversible reaction. Okay, so this was about weak acid. Okay, and that is why this is called as weak acid, because it cannot be ionized completely. The one which ionizes completely is the strong acid, and the one which partially ionizes or doesn't ionize completely is the weak acid. Okay, now let us see about strong and weak bases. Okay, so strong base and weak base. Strong base, it is the base that ionizes completely in the solution. Again, it will be in the terms of ionization. So base which ionizes completely in the solution is strong base, and it is going to give off greatest number of hydroxide ions when it is placed in a solution. Now here the difference is, in acid we were having hydrogen ions, but in base we are going to have hydroxide ions coming out. Okay, so this dissociation will be of hydroxide ion. Okay, so this strong base is going to give more amount of hydroxide ions when it is placed in a solution. Example is sodium hydroxide. When it is going to split off or ionize, it is going to give Na plus plus OH minus. So what is this OH? This OH is hydroxide ion. So here we were having only one OH, which has been completely dissociated out from Na. Okay, that is sodium. Okay, so this is what is called as complete dissociation and giving off of the hydroxide ions. Opposite to this will be seen in weak base. In weak base, the base is not going to ionize completely. Okay, it doesn't ionize completely in the solution, and it gives off less number of hydroxide ions. Okay, so here we will have less number of hydroxide ion. When we talk about this, here it is ammonia, and it gives NH4 plus OH minus. Okay, so here one hydroxide ion is given, other H3 is still there, other hydroxide ions are still there in the ammonia. Okay, so ammonia is the example of weak base, and sodium hydroxide is example of strong base. Okay, now next is when we compare, not compare, when we mix acid and base together, we get salt. This we have already seen. Okay, NaCl formation we have seen in our last to last video. Okay, so acid plus base is always going to give us salt, but these salts are of different types. Okay, depending upon which type of acid and base is taken. Okay, which type of acid and base is combined. So we have three types of salt depending on the nature, depending on the type of strength of acid and base. First is acidic salt, then basic salt, and then neutral salt. Now how they are different from each other, let us see that. When we talk about salts which is having strong acid plus weak base. Okay, so strong acid and weak base, when we combine these two, we are going to get acidic salt. Okay, so remember this, when we talk about acidic salts, the answer will be strong acid plus weak base. When we talk about basic salt, the answer will be weak acid plus strong base. They are going to give us basic salt, right? And then when we combine strong acid plus strong base, okay, strong acid plus strong base and weak acid plus weak base, here their strength is similar. You can see acid and base, their strength is similar. Again, this acid base, both are weak, both are strong. So in this condition, we are going to get neutral salt. Okay, so acid salts, we get it from when the acid is strong and the base is weak, Basic salt we get it when the acid is weak and base is strong, and neutral salt when we get it when the nature of both acid and base, so not nature, strength of both acid and base is same, that the acid and base both are strong or both are weak. In this condition we get neutral salts. Okay, so this is how we get different types of salt in different condition when we add different strength of acid and base together. I hope this much is clear, very much clear to you. If you have any doubt, you please let me know. Thank you for watching the video.